Hey everyone! Look, whether you're a developer, a manager, or honestly just someone who uses apps on your phone, there are these core ideas that decide if software is great or, well, not so great. Today we're going to break down the 7 key principles that really separate the good from the bad.
So, let's kick things off with a statement you've probably heard a million times. Maybe you've even said it yourself. If the tests don't find any bugs, the software must be perfect. Sounds about right, doesn't it? Totally flawless, ready to ship.
Yeah, that's just not true. At all. In fact, it's probably one of the biggest myths in the entire software world. And really, getting why it's a myth, that's the secret sauce to understanding how professional quality engineering really works. So, here's what we're going to cover. We're going to take those 7 principles and group them into 5 main ideas. We'll talk about why perfect software is a total myth, what testing just plain can't do, and then how to test smarter, not harder. After that, we'll see how to keep your tests sharp over time, and wrap up with the real goal of all this quality stuff. Let's get into it. All right, first up, let's tackle the biggest idea of all: what does testing actually prove? And that leads us right into principle number 1. Testing shows the presence of defects, not their absence. Now, to really wrap your head around that, let's use a super simple, everyday example. Okay, picture this. You're buying a used car. You do your due diligence, right? You kick the tires, you test the brakes, listen to the engine, flick the lights on and off. Everything seems to check out. So, does that mean the car is guaranteed to run forever without a single problem? No way. Of course not. All it means is that, for the things you checked, you didn't find an issue.
And boom, that's exactly how software testing works. It can prove that problems are there, but it can never, ever prove the problems aren't there. Finding 0 bugs just means that in the specific scenarios you ran, nothing broke. But what about that one weird edge case or a new operating system update? See, that's the key takeaway. A great tester isn't promising perfection. They're giving you confidence by showing you what's been checked and what the risks are.
So, if we can't prove there are no bugs, that leads to the next logical question, right? What are the limits here? Why can't we just test everything?
Well, that brings us to principle number 2. Exhaustive testing is impossible. And that might sound a little dramatic, but trust me, for any piece of software that's more complex than a Hello World app, it's just a fact. You literally cannot test every single possible thing.
And why is that? Well, just think about it for a second. In any real app, you've got maybe thousands of different ways a user could click through the screens. You've got an almost infinite number of data combinations they could type into forms. Then you've got all the different phones, tablets, laptops, browsers, not to mention different network speeds. And every single user is a little bit weird in their own way. Trying to test every single one of those combinations, it's not just a bad idea, it's physically impossible.
Okay, so if we can't test everything, are we just doomed? Nope. The goal has to shift. The real goal isn't to test everything, it's to test the right things. It becomes a game of strategy. You have to focus your fire on the most important user journeys, the riskiest new features, and the parts of the app that would cause the most pain if they broke.
Which leads us perfectly into our next big idea: how to test smart. Since our time and money are always limited, where do we point our efforts to get the biggest bang for our buck? The first piece of the puzzle is principle number 3, early testing. And to get why this is such a game changer, let's use another great analogy: building a house. Think about it. If the architect spots a mistake on the blueprint, what does it take to fix? An eraser and a pencil. Super cheap. But what if you don't find that mistake until the house is built and the family's moving in? Now you're talking about tearing down walls, maybe even demolition. The cost goes through the roof. And software is exactly, and I mean exactly the same. A bug found in the design doc is an easy fix. But that same bug found by a customer? Oof. That's a 5-alarm fire for your budget and your company's reputation.
Okay, so we're testing early, but where do we look? That's where principle 4 comes in: defect clustering. You've probably heard of the 80-20 rule, right? Well, it applies big time to software. Time and time again, we see that something like 80% of all the bugs are hiding in just 20% of the code. So instead of testing everything with the same level of intensity, you go on a hunt. You find those super complex, risky, or constantly changing parts of the app, and you hit them hard with your best tests.
All right, so we're testing early, we're focusing on the hot spots. But how do we make sure our tests don't get stale? How do we keep them effective, month after month? Well, it's all about adapting.
And this is perfectly captured in a concept with a great name. Principle number 5 is the pesticide paradox. And yeah, it's exactly what it sounds like. It comes from farming, where if you use the same pesticide over and over, the bugs eventually just become immune to it.
A great way to think about this is your workout at the gym. If you go in and do the exact same 3 exercises with the exact same weight every single day, forever, what happens? You plateau, your body adapts, and you stop getting stronger. Well, software tests are no different. If you just run the same old tests over and over, they stop being good at finding new bugs. To stay effective, you've got to mix it up. Review your tests, add new ones, try different things.
Adapting also means knowing that there's no one-size-fits-all approach to testing, and that's principle 6. Testing is context-dependent. I mean, think about it. Are you going to test a simple calculator app on your phone with the same intensity as you would a major online banking platform that handles millions of dollars? Of course not. The risk is completely different. Your whole testing strategy has to be tailored to the context. You got to ask, who's using this? What happens if it breaks? How much does this matter to the business?
And that brings us to our last principle, and honestly, this might be the most important one of all, because it asks the big question, what are we even doing here? What's the real goal? Because it's not just about counting bugs.
Okay, let's wrap this up with our final principle, and again, an analogy makes it crystal clear. Imagine you're an engineer and you build a bridge. It's a masterpiece, structurally perfect, not a single flaw, but it connects the wrong 2 cities. So, the bridge is technically flawless, but it's completely useless. And this gets us to principle number 7, the absence of errors fallacy.
And that is the whole point. You can have a piece of software that passes every single test you throw at it. 0 bugs, not a single crash. But if it doesn't actually solve a real problem for the user, if it isn't useful, then it's a failure, period. Bug-free does not mean useful. Finding no errors is not the same thing as creating value for someone.
So I'll leave you with this final thought to chew on. The ultimate goal here isn't just to make something that doesn't break. It's to deliver the right thing that actually helps someone. So ask yourself this, is the software you're building just bug-free, or is it genuinely useful? Answering that question, well, that's the difference between just testing software and building real quality.